Integrated Math 3, this is the test review for the final exam. So this is going to look exactly like the exam looks, except I'm giving you questions with different numbers. So let's go ahead and get started on this. It's not a long exam. I eliminated a couple of the problems. So if it says no problem, that means there's nothing to do. You don't need to do any problem for that. Okay, let's go ahead and get started. So number one, a recent college graduate accepts a job at Google. The job has a salary of $65,000 a year and is guaranteed a pay increase of 2%. What is his salary after 5 years in the company? Okay, so simply the formula you use for this is this one. The amount he's going to earn is equal to what he starts with, 1 plus the interest rate, which we call R, raised to the power of the number of years. Okay, how that formula is derived you don't have to worry about at this point, but it's just simply the formula you're going to use. So plug in the numbers. Okay, now 2%, you have to convert that to a decimal number. So you just do it right here. So 2% means 2 per 100. That's what percent means. If you do that on your calculator, 2 divided by 100, you get this, 0.02. And it's to the 5th power because there's 5 years. Okay, so go ahead and add these two together. You get 1.02. So you take 1.02 and you caret, the little caret right there, you raise it to the 5th power and you get 1.104. Okay, and you multiply that times 65,000, and that gives us 71,765, and you don't have to put any pennies down, and that's dollars, and that's your final answer. Okay, so that is how you do that. All right, next one. This is a common base type of problem, so you want to have both of these with a base 3. So 81 is 3 to some power, and you don't know what it is, so you just start multiplying. 3 times 3 is 9, times 3 is 27, times 3 more is 81. You can just do that on your calculator. So it's 3 to the 1, 2, 3, 4, 3 to the 4th power. So we're going to rewrite this as okay, so 3 to the 4x minus 4 equals 3 to the 4th. If these two numbers are equal and 3 raised to this power equals 3 raised to this power, then the this powers have to equal each other. This has to equal that. If you wanted to do it properly, I'll show you, but you do not have to do this for credit on the test as long as you set that up properly. You would say log base 3 of okay, so you just realize that when you take a log base 3 of 3 raised to a power, they inverse each other. The log base 3 goes away and that 3 goes away right there. Same thing on the other side. So what you're simply left with here is 4x minus 4 equals what's in here, which is 3 to the 4th. Excuse me, not 3 to the 4th, just the 4. That log base 3 eliminates the 3 there because they inverse each other. So that equals 4. So now it's just a simple algebra problem. And I'll come over here. x equals 8 over 4, so x equals 2. Okay, and that is that one. All right, next up. Okay, they're asking us to expand this. That means you're going to end up, I gave you a hint, you should end up with 3 log terms, okay? So that means you're going to end up with a lot of log terms. You're going to expand this out. So the basic principle is that's on the sheets, and I put the formula sheets in. They're going to be up by 9 o'clock on Thursday morning. They're not up in the Canvas yet, but they will be. Okay, so the principle is this, that AB means A times B. I'll put a little dot there. Doesn't matter what the base is. The other one is this, log of A divided by B. Okay, so you're going to use that principle right here, okay? And so what that means is you have log 4. We'll start off with log 4x raised to the 3rd power. So I'll do this over here. And then these are on the bottom, just like the b is on the bottom of this. So these are going to be subtractions, just like that's a subtraction right there. Okay, and that's what that would look like. There's 2 subtractions because both of these are on the bottom. Okay. The only other step is you take the exponent and you put it out in front. That's a principle of logs. If you have an exponent inside of a logarithm, you can take that exponent and put it out here. So it's going to look like this. So it's no longer up there, so you don't see it there anymore. And this step is required to get credit on the problem because that's part of expanding, okay? So that's the final answer right there. All right. Condense. That's going in the opposite direction. It's just doing exactly the opposite of what this did, so you end up with something that looks like that with a single log. Okay, so we have, and I didn't correct this error. That should be a base 4 there. I'm sure I corrected it on the test. So everything should be the same base. It's base 4. All right, and so, and I think the other thing I did was on the review, I made this a minus sign. Okay, so I just didn't get those changed here. Okay, so make that a minus sign just so it just makes the problem a little more inclusive. It gives you a little bit of everything. Okay, so here we go. So we have log A. So we're going to say log of A on the top. So we're going to have a top and a bottom because we have a minus sign there. And it is B, and there's a 7 here. So you're going to do the opposite of what you did in this step. You're going to put the 7 and make it an exponent of B. So it's going to become B raised to the 7th power. Again, the 7's a coefficient, so now you put it back up there, just like when we had them up here. We put them out in front. We're doing the opposite. It's just the opposite of this problem. And finally, you have 1/2 C. Okay, and these are all plus signs, so these are all going to go up on the top. So that's going to be C to the 1/2 power. And then minus D, there's no coefficient there. So it's just, but the D is going to go on the bottom because it's a minus sign. And no exponent because there's no coefficient there. All right, and that's the final answer for that. Okay, that's all there is to that. All right, in problem 5, by the way, this said 3, and again, that was a correction I should have made. That should be problem 4. Okay. All right, problem 5. is you're supposed to solve for x. You have a couple logarithms. So the first thing we do is we condense this the way we did right here. So it's going to look like this. This minus this means the x plus 2 goes on the top. And it's minus, and then there's a 6 there that goes on the bottom. And that's going to equal 2. Alright, so we have to inverse this. So what we do is we take this whole expression and we raise it to the power of whatever this base is. That's how you do an inverse. Many of our problems, it was a 10, but it's not a 10 now. But whatever that base is. So we're going to take the number 5, I'll write it kind of big right there. It's going to be raised to this entire thing. And since we raised all of this, raised 5 to this power, we got to raise 5 to this power. Okay, so there that is. So 5 raised to this equals 5 raised to 2 to the second, then 2 has to equal all of this. Those two have to be equal. Properly, the way to do it, anyway, it doesn't matter. The 5 raised to log base 5 inverses it. Those two inverse each other. And then that's just 5 squared. So what you end up with is this, just that. So I'm going to come up here. Then 5 squared is 25. Okay, now it's just an algebra problem. Multiply both sides by 6. Cancels. 25 times 6 is 150. Subtract 2 from both sides. And you're just left with x over there, and 150 minus 2 is 148. And that's the final answer for that. Okay. Six. I didn't have that question number 6 when we did it in class. I'm going to just eliminate it. There is no question 6. Alright, so we're going to move on to question 7. On a circle, a line is drawn from the origin to -3, -4. The angle theta between the line is between the line and the x-axis. Find the cosine of theta. Let's go ahead and draw that circle. Something like that. Okay, so -3, -4, you start at 0, 0, and -3 means you move back this direction. I'm going to move it just right about to, I'm going to say right there. And then -4 is your y coordinate, you're up and down, and that's going to go down to there. So it's going to end up on the circle. It has to end up on the circle. And so I might do a little better than that, I think. I'm going to put 3 right about there, and then 4 comes down to there. It's not that important. It's just a sketch. I just want 3 to look like it's longer than 4. Okay, so it's going to come to here. And then down to here, something like that. Okay, so this is -3. You went back 3, and then you're going down 4. This is -4. So if you draw this, this is a triangle. Now it's not a unit circle. That's not a radius of 1. It's a radius of what we're about to figure out. Okay, so that's not a unit circle. It's not a radius of 1 right there. We're going to figure out what that radius is, which is the hypotenuse of our triangle. So we'll call it C. So c squared equals a squared plus b squared. -3 squared is +9. -4 squared is +16. C squared. C squared therefore equals 25. Take the square root of both sides. you get c equals 5. Okay, so the reference angle again is the shortest angle between the line, this line right here, and the x-axis, which is right here. So it's this angle right here. It's called the reference angle. So that's our angle theta. We don't know what that is. And the problem doesn't even ask for it. It asks for cosine of theta. So let's remember which side is which. Okay, the hypotenuse is this side, the long side. The side opposite the angle. So here's the angles. The side over here is the -4 side. That's the opposite. And the other one is the adjacent, the one next to the angle that's not the hypotenuse. Okay, so what is cosine? Go back and review your principle. Okay, so here they are. So cosine is adjacent over hypotenuse. Adjacent over hypotenuse right there. Okay, so the adjacent is the -3, the hypotenuse is 5. And that's the cosine of theta. So cosine theta equals, you don't have to calculate what 3 divided by 5 is, you just leave it like that. And that's your final answer. Okay, number 8. Using the unit circle, determine the value of cosecant of 2 pi over 3. So again, we'll come back here. And what's a cosecant? Well, you come right here, and you should write these in if you haven't already, what a cosecant is. It's the hypotenuse over the opposite, but in terms of sines and cosines, it's 1 over the sine. It's the reciprocal of the sine. And what's the sine of 2 pi over 3? So you get your unit circle and bring in the unit circle, and there's 2 pi over 3. And if we remember, we have these pairs right here of coordinates. And the first one is the cosine right there, and the second one is the sine. Okay, so the sine is square root, it's positive, by the way, it's a little hard to see the negative sign. It's positive square root of 3 over 2. So the sine is, so we're going to put 1, that means it equals 1 over the square root of 3 over 2. Alright, so anytime you have a bottom of a fraction on the bottom of the fraction, you just flip it. So that's 2 over the square root of 3. Okay, I will accept that as a final answer. You should rationalize that simply by multiplying both top and bottom by square root of 3. Okay, and that will equal, the square root of 3's cancel, and you have 2 over, excuse me, I did that wrong. What did I do that for? Sorry. I was thinking of a different problem. They would cancel, but that would put us right back where we started. That's not what we want. So now it's 2 times the square root of 3. And square root of 3 times square root of 3 simply equals 3. So that's your final answer. Or I will take that, what you got there. I would take that as well. All right. Okay. There we go. Okay, number 9 is no question. I have eliminated that, so there is no question 9. Move on to 10. Okay, 10 might be the toughest problem on the, at least it requires the most calculations. So given that sine of theta equals -3 over 5. Now notice where the negative sign is. You don't know, and even if they had written the negative sign up top, you don't know which one is the negative number. One of those two has to be negative. But sine of theta equals -3 over 5, and tangent theta is greater than 0. Find cosine and cotangent. Okay, so there's a lot to do here. So first thing, let's define what a tangent is. Tangent is a sine over a cosine. Okay, that's step 1 to think about. Now, if tangent theta is greater than 0, it means it's a positive number. It's going to be a positive number. What that means is that both the sine and the cosine have to be positive, or both the sine and the cosine have to both be negative, right? Because in order to make this a positive number, they have to both be positive, or they have to both be negative, so you have negative over negative turns into a positive. Well, since we see right here that sine theta is negative, then that means that cosine must be negative as well. So what we're going to do is draw a circle over here, like we did on the previous problem. Okay. And we remember that sine equals opposite over hypotenuse. So that means it's going to be -3 is the opposite and 5 is going to be the hypotenuse. The hypotenuse always has to be a positive number. Now, since we know both sine and cosine are negative, we know that this is going to fall somewhere in this quadrant over here. Somewhere in there. That whole thing's going to fall in there, because that would be a negative cosine would get you back here, and a negative sine would go down. So it's going to be somewhere in there. All right, we know that the tangent has to be a positive number. Because a squared plus b squared equals c squared, and that means c squared's got to be a positive number. So we're just going to draw a line here. It doesn't really matter where. And we're going to make a triangle. And so what we just said is, here's the angle right here. And so the opposite is the -3. And the hypotenuse is the +5. Again, the hypotenuse has to be a positive number, so we know it couldn't have been +3 over -5. It has to be -3 over +5. Okay, by now I'm just going to say you should recognize this as a 3, 4, 5 triangle. And this side is going to be -4 because it's in the negative direction, negative direction. So -4 squared is 16, -3 squared is 9. You add 16 and 9, you get 25, and the square root of 25 is 5. That's just the Pythagorean theorem, okay? So that's our sine. So if that's our sine, our cosine has to be this. It's adjacent over hypotenuse. And that's going to be -4 over 5. So there's one of the answers right there. And be sure you circle your answers, by the way, especially if you're going to do a lot of work. Okay, so that's the cosine is -4 over 5. You don't have to change it. They don't ask you what the angle is. They just ask you what the cosine is right there. Now, cotangent is the reciprocal of the tangent. Okay, so we have the sine right here, -3 over 5. We have the cosine, -4 over 5. So let's write the tangent first. Well, we don't have to. Let's just go ahead and write the cotangent. So what is, I'm going to write down here, steal a little space down here. So the cotangent equals, the tangent is sine over cosine, cotangent is reciprocal of that, it's cosine over sine. All right, well, we know our cosine is -4 over 5. And the sine is -3 over 5. Okay, so you have a fraction over a fraction, and once upon a time you learned how to multiply that. You take the top, you leave it alone, -4 over 5, you multiply it by the bottom flipped over. So that's going to be -5 over 3. All right. You flip the bottom and multiply. So the 5's cancel out. You have a negative times a negative is a positive. So you end up with 4 over 3 for your final answer. Let me just write it out. So cotangent of theta, which is what they're asking for here, equals 4 over 3. And there's the answer. So those are your two answers right there. Okay? All right. Okay, so now we move on to problem 13. Here it is. It's cosine theta. They want you to find what theta is. This is a problem where I made a mistake. I won't go into the explanation of the mistake other than to say this. Change the 6 to a 12. Just do that. Otherwise, the problem won't work. Don't worry about why. It just won't work. Okay. So that's going to be a 12 there. So we need to solve for theta. So let's get cosine theta by itself. We're going to divide both sides by 12. 12 cancels here and here. And so what you end up with is this. Okay, 5 square root of 2 over 12 on this side. Okay, it's cosine theta. All right, now we've got to do the math on that. So we come here, we do a second x squared, which gives us a square root. Put the 2 in there, close the parentheses, equals times times 5 divided by 12. And that gives us, let me try that again, times 5 divided by 12. Wanted to double check that. Yeah, something seems wrong. So it's 0.56. 0.56. Okay, so now to get this out of the cosine, I have to use an inverse cosine. So I have to use the inverse cosine on the other side as well. Okay, so inverse cosine of cosine simply gives you theta. An inverse cosine of this is going to be second cosine, and it's 0.56. And that gives you an angle of 55.9 or 56, we'll call it. Degrees, and that's your final answer. All right, number 14. They want you to find all of the sides and all of the angles. So we'll go ahead and do that. So to use law of sines, you have to have an angle and its corresponding side. So you have to have angle B, side B, or angle A and side A, or angle C and side C. And let's go ahead and label this. If this is angle C, this is side C. And if this is angle A, then the opposite is side A. Well, we don't know any of those pairs. We know angle B, but not side B. We know side C, but not angle C. We know side A, but not angle A. What that means is you can't use the law of sines, which is a little bit easier to do. So we're going to use law of cosines. And again, you can get that straight off of your sheet here. So you have 3 different versions of it, but it's the same equation. But what do we know? We know side A, C, and angle B. So we're going to use this second one, because side A we know, C, we know, and angle B we know. So we're going to use this version of it, the middle version here. Okay, so there's a formula. Now we just plug in the numbers. Side A is 6. Okay, and the cosine of the angle that we know is 85 degrees. That's going to be 96 times the cosine of 85. So we'll just go on our calculator and find out what that is. And it's this. Okay, now we just do the math on this. We do this first, multiplication. Remember, all of this that we're doing equals b squared, equals that, okay? So, and I think I just called this, I rounded this to 4, I think, in class. Let me do that here. Okay, if you do that, you end up with 91.6 for all of this. Okay, so we take the square root of that, and it gives us 9.6. So the square root of b squared, square root of this, b equals 9.6. Okay, so that's this side here, so that's 9.6. All right, now we have all three sides, and now we have a side and a corresponding angle. We have angle B and we have side B. So now we can use the law of sines to figure out one of these. We're still trying to figure out these two angles here. So let's go ahead and do A. All right. So the law of sines says that the sine of B over side B equals the sine of A over side A. We could have used C, but we're going to go ahead and just decided to use A. Okay. So let me do that up here. Okay, so let's plug it in. So sine A, that's sine of this angle. We don't know that angle. That's what we're trying to find out. Side A is 6. Sine B is 85. Sine of 85, sine 85. And side B is 9.6. Okay, so we have to get sine A by itself, so we need to multiply both sides by 6. So I'm going to put a times 6 here and a times 6 here. These two cancel, and you end up with sine A equals all of that. It equals sine of 85 times 6 divided by 9.6. That'll give us sine A. Okay, and that gives us this. So now we need to use an inverse sign to figure out what A is. Okay, so inverse sign of sine A is simply A. And inverse sine of this, we're going to do second sine. That gives us the inverse sine of 0.62. Close the parenthesis, and that gives us an angle of 38.3. And we're going to just round that to 38. And that's our angle A, so that's this. Okay, so just one more thing to go, so find angle C. We know all the sides and we know two of the angles. We know that all three angles in a triangle have to add up to 180. So if I take 180 and I subtract 85, which is angle B, and subtract 38, which is angle A, that will give us angle C, which equals 57. Okay, and when you do the problem on the test, I would like you just go ahead and write them so I can just look at that and see if you have the answers there. Okay, you do have to show the calculations, but go ahead and write them on the triangle where you did that. Okay, all right, that takes care of that problem. One more to go. All right, so from the top of a fire tower, forest ranger sees his partner on the ground at an angle of depression of 54 degrees. If the tower is 38 feet high, how far is the partner from the base of the tower? So here's the tower. And here's the ground. Okay, now here's a person standing up here. With this question, the way it's worded doesn't take into account is that this person has some height. Their eyes are actually up here on their face, but we're going to measure from here. And the partner's down here, and the partner's eyes are up here on the partner's face, but we're going to measure from right here. And it's interested not in the distance between them, but in the distance to the base of the tower. That's this right here. So we have a triangle. I would like you to draw the diagram too, okay, and label it. So there's a triangle right there. Now an angle of depression means how much is he looking down, okay? And again, we're assuming he's looking from right here. So I'm going to draw a line parallel to the ground. It doesn't really exist, it's just kind of an imaginary line, okay? So the angle of depression is this angle right here. That's how much he's looking down. From looking this way to looking down, it's that much. So that's 54 degrees. I rather deal with this triangle. This is our triangle. So one principle is if this line is parallel to this line, and it is because I drew it that way, then this angle, these are opposite interior angles, is also going to be 54 degrees. Okay, so now we're just dealing inside of our triangle here. We're not dealing with this up here. All right, so that's 54. Then you have two parallel lines and a line that goes between them. Then those angles have to be 54 as well. Okay, so what else do we know? We know the height of the tower is 38. Okay, so that's all the numbers we know. So we have a triangle, and it has a hypotenuse right here, and the opposite side is over here, so that's the 38 is the opposite. And it has this side here, which is the adjacent. Okay, and so what we know is the opposite. What we're trying to find is the adjacent. We don't really care about the hypotenuse. They didn't ask us for this distance. So we know this, we're trying to find this. So the relationship between opposite and adjacent would be a tangent. It's opposite over adjacent. That's the one we know. That's the one we're trying to find out. Okay, so let's fill in our numbers. The tangent of theta, or the tangent of 54, equals the opposite, which is 38, over the adjacent, that's what we're trying to find out. That'll be our answer. That'll be the distance that this person is from the tower. Okay, I got cut off there a little bit. So tangent is opposite over adjacent, so it's tangent of 54 degrees. It's 38 over adjacent. 38 over this. Okay, so we're going to multiply both sides by adjacent. We need to get adjacent by itself, and we need to get it up on the top. So we're going to multiply both sides by adjacent. Okay, so multiply both sides. These two cancel. Now I have to divide both sides by tangent 54. These two cancel. So I have adjacent all by itself right there. Okay, so 38 divided by tangent 54, close the parenthesis, and it gives me 27.6. We'll round it to 28. And that's in feet. So adjacent equals 28 feet, and that's the answer. That's the answer right there. That's how far this person is from there. Okay, so I'm recording this on Thursday early in the morning, and it's due on Saturday late in the afternoon, 5 o'clock. It does need to be on time to get full credit, so be sure you get it in on time. That's more than 2 full days. So get that in, and if you have any questions, I'll have tutoring this week, and that's it. Have a good day.